Welcome. This is Form 3 Mathematics and the topic today is vectors. So the question reads, the diagram below shows a triangle OPQ in which QN to NP is 1 to 2 and OT to TN is 3 to 2 and M is the midpoint of OQ. So before I continue, let me interpret the ratios first. So we have Qn to Np is 1 to 2. So you have Qn to Np. Qn therefore is 1. Np is 2. We are also told OT to Tn. So we have OT being 3. and Tn being 2, and then point M is the midpoint of OQ, so that is 1 to 1. Given that OP, vector OP is P, so OP, that's a position vector, so from the origin, so the arrow points away from the origin, and then OQ also we have as that. So OP we are told is P. OQ we are told is Q. So express the following vectors in terms of P and Q. So we're going to begin with PQ. So PQ is simply you're moving from P and you're heading to Q. So we can take the vector PO and then OQ. So vector PO plus OQ. So remember, vector PO is against vector OP, that is against the direction of OP. So we simply have it as negative OP plus vector OQ. OQ, that is in the direction of vector OQ, so there's no problem there. So we've been told that OP is P, so for OP we will simply have this. So OP is P, so we have negative P plus OQ is Q. OQ is Q, so we have Q. You can even rewrite this as Q minus P, which is just the same result. Okay, so for the second part, Roman 2, we are to get ON, and in order to get ON, then you're simply going to have to move as follows. So you can move from O to Q, then Q to N, or OP, then PN. So we can choose to move from OQ, then QN, but QN would be given as follows. QN, remember, is a fraction of QP, which is just 1 out of a total, which is 3. So QN is a third of QP. That simply means QN is equal to a third of, remember, QP is against the direction of PQ. QP and PQ are in opposite directions. So if you're moving from Q to P, then that is simply the negative of PQ. So what you're simply going to have here, instead of having Q minus P, we are going to have P minus Q. So it's going to be a third into P minus Q. So this is for Qn. So finally, for that bit, we can get On, which is simply OQ, but OQ is Q, plus Qn, but Qn is a third P minus Q. So from here, we can therefore say On is equal to Q minus a third Q plus a third P. So finally, we can say that On is a third P plus 2 over 3 Q. Now this can also be simplified further to 2, or rather a third into 2Q plus P. But you could as well even leave it at this particular point. So that is for On. Next we look at PT. So for PT, we are simply going to have PT is PO plus OT. So PO plus OT, but OT is simply 3 over 5 of On. So OT is simply a fraction of the whole of On. So that is 3 over the whole, which is 5 of On. So we have 3 over 5 of On. But fortunately, On we had gotten right here. So we can say OT is equal to 3 over 5 into On, and On is a third into 2Q plus P. So this simply gives us 1 over 5 into 2Q plus P. And therefore, PT right here becomes PO, and PO is against the arrow, against the direction of OP, so we make it negative OP, and negative OP is negative P, plus OT, and OT we already have as 1 over 5 into 2Q plus P. Now, opening the brackets and simplifying, we will have 2 over 5Q minus 4 over 5P. So that is it for PT. For PM, PM is simply, we are moving from P to M, so PM is simply PO plus OM. So you say PO plus OM. So that is going to be, well, we need to look for OM. OM is simply a half of OQ. Well, OM, point M is the midpoint of OQ, therefore OM is a half of OQ. So that's why we have it like that. But OQ is Q. So OM is simply a half Q. So that PM would therefore be given as PO, which is negative P, plus OM, which is a half Q. So that is for PM. Next, for part B, show that P, T, and M are collinear. So in order to show that P, T, and M are collinear, we will use a pair of vectors that contain P, T, and M. So we can pick from the previous part, we have PM and PT. So what we are going to show is that PT is parallel to PM. So how do we show that? We simply show that one is a scalar multiple of the other. So you can say PM is equal to H PT, where H is a scalar. So if we are able to show that PM is a scalar multiple of PT, then that proves that the two are parallel. Another thing we need to show is that there is a common point, which in this case is obvious. Point P is shared for both PM and PT. So let's show that PM is parallel to PT. So you already have PM, or PM is right here, a half Q minus P is equal to H into PT, but PT we also had as 2 over 5Q minus 4 over 5P. So from here, open the brackets so that you have a half Q minus P is equal to 2 over 5H Q minus 4 over 5H P. So we can equate the Q's or the P's in order to get H. Let's say a half Q is equal to 2 over 5 HQ. So the Q's will cancel as we divide both sides by Q, so that here H becomes 5 over 4. So if H is 5 over 4, then you can come and conclude that PM right here is equal to 5 over 4 of PT. Remember, even if we had used P's, negative P is equal to negative 4 over 5 HP, you will still get the same result. Therefore, PM is parallel to PT because PM is a scalar multiple of PT, so 5 over 4 is a scalar, and P is a common point. So there's a common point. Hence, P, M, and T are collinear. Lastly, we are asked to determine the ratio M to TP. So what you're going to do is this. We have PM is equal to 5/4 PT, of which if we divide both sides by PT, we're simply going to have PM over PT is equal to 5/4. So if you have that as 5/4, then what you're simply going to have next is, from the diagram, if you know PM is 5 units, PT is 4 units. So where's PM? PM is 5 units, PT is 4 units. So PT is 4 and PM is 5. So that means TM is 1. So from there, we can come and conclude that the ratio of MT to TP is simply, so MT is 1, TP is 4. So that is 1 to 4. So that marks the end. Thanks for your patience. Thank you for watching, and see you next time.